The James Webb Space Telescope is now 1 million miles from Earth and performing science operations. The Nancy Grace Roman Space Telescope is scheduled to launch by 2027. These two observatories are NASA's latest flagship missions in the tradition of Hubble, Chandra, and Spitzer. But why do we need both? And why do they look so different? The answer to both questions is that they are built to do different things. Webb has the exquisite sensitivity and wavelength range to capture detailed images deeper into the universe than ever before. Roman has an incredibly wide field of view to rapidly survey huge areas of sky while still rivaling Hubble and Webb's resolving power. Webb will tell us about the early universe, and Roman will help us understand how it evolved from there. One of the keys to Webb's sensitivity is its huge mirror. At more than 21 feet wide, it's the largest mirror that has ever flown in space. By using such a large mirror to collect more light from faint objects and observing in infrared wavelengths, Webb will peer deep into the distant, early universe. The universe's expansion stretches light traveling through space, a phenomenon called redshift because the light waves we receive from receding objects are stretched to longer, redder wavelengths. Webb is designed to see this redshifted light so that it can study the first, most distant galaxies. The Roman Space Telescope, on the other hand, isn't trying to see quite as deep into the universe's history. Roman does have filters to see infrared light, but not as far into the range as Webb because its targets aren't as redshifted, and Roman's mirror can be smaller because it isn't trying to detect such faint objects. That wavelength difference affects another very visible feature of the two spacecraft. Webb observes light near the same wavelengths that the spacecraft itself would emit if it were not cold. As a result, Webb has a very robust system, including the multi-layer sun shields, to keep it extremely cool. Roman, on the other hand, needs far less cooling because it will observe in wavelengths unaffected by a warmer spacecraft, so the shade provided by its solar panels alone does most of the work. While Webb will peer with intense focus at very specific objects and regions, Roman is a survey telescope designed to capture vast swaths of sky, but it will do so with revolutionary precision, sensitivity, and depth. The key to doing this is the heart of Roman's wide field instrument, a massive camera with 18 next-generation detectors. Each one captures a 4,000 by 4,000 pixel image, and together they will take pictures covering 100 times more sky than either Hubble or Webb. This wide view will allow Roman to study enough large-scale structure of the universe in high precision for scientists to begin understanding its true nature, including dark energy and dark matter, and viewing early galaxies as a population rather than a few individuals who may or may not be average. Both telescopes will also help us learn more about planets outside our solar system, called exoplanets, but in very different ways, with Roman finding more that were previously undetectable, and Webb gathering new details on those already discovered. These two telescopes, with their different but complementary goals and strengths, will help us understand much more about the early days of the universe, how it has evolved since then, and what other worlds might be out there.